Okay, Course 3, Lesson 3, Addition and Subtraction Word Problems. Objective, you'll be able to write and solve word problems involving subtraction and addition and finding missing numbers. All right, so our first question here, 38 cars are waiting to take a ferry across a lake. And as I'm reading the question, I kind of just like to identify information. So we got 38 cars. The ferry can carry 6 cars. If the ferry starts on the same side of the lake as the cars, how many times will the ferry cross the lake to deliver all 38 cars to the other side of the lake? All right, I'm just going to write some of this information in a new page here just so we can capture it clearly. So we got 38 cars in total. So here the ferry can carry 6 cars. And then if the ferry starts on the same side of the lake as the cars, how many times will the ferry cross the lake to deliver all 38 cars to the other side of the lake? Okay, so let's go ahead and look here. So we got 38 cars. This is on like one side of the lake. So if I just kind of draw a picture, I'm just going to say that this is the lake. And then so the ferry, I'm just going to say we got 38 cars here. This is our ferry. I'm just going to label it F. And this is the other side. So it says, how many times will the ferry cross the lake to deliver all 38 cars to the other side of the lake? All right, so let's see here. So I'm going to go ahead and do 38 cars, all divided by 6 cars. So we see here that's going to be, it looks like it's going to be 6 trips, and then there's a remainder of 2, so that's going to require 1 more trip. So what we notice though is that a trip, you have to go across the lake, drop off the cars, and then go back. So we had that 6 times, so that should give us 12. And then lastly, we had that 2 cars left over, so we have to go back there again. So it looks like, so plus 1 more trip equals 13 total trips. Okay. Yep, and I just want to make sure I answer the question. How many times will the ferry cross the lake to deliver all 38 cars to the other side of the lake? So yeah, so technically totally crossing the lake is 13. It has 6 full trips and then one more trip to finish up taking those 2 cars over there. All right, so our Power Up A was done on the Google form. So now looking at a few things here. So in order to solve story problems, we can use variables to represent missing numbers. So looking at this, we see the first half of the game, Heidi scores 12 points. Just going to underline that. I already underlined some of it. Whole game, she scored 27 points. How many points did Heidi score in the second half? So that's what we're trying to solve for. So our variable is going to represent the points, how many points Heidi scored in the second half. So write an equation to solve. So therefore, let's do the first half plus the second half equals the total points. So therefore, it's going to be 12 points, all plus, we don't know the second half, so I'm just going to write x. Again, the variable just represents an unknown. That's going to give us the total points of the game. So let's go ahead and do take away 12, take away 12. So it looks like x is going to be equal to 15 points in the second half. So let's go ahead and check that. So if we had 12 in the first half plus 15 in the second half, we see the 5 and the 2 give us 7, 1 and 1 give us 2, so it is going to be 27 points, so therefore the second half is indeed 15 points. And I'm just going to go ahead and throw my label of points on there as well. All right, so we can use variables to represent missing numbers, so still looking at this. So Fred went to the store with a $20 bill. Okay. He bought a loaf of bread and a half gallon of milk. The clerk gave him $15.17 in change. So how much money did Fred spend if he got $15.17 back? All right, I'm going to go ahead and write some information down on a new page. So he had $20, and then the change was $15.17. So we're trying to figure out how much did he spend. So we don't know how much he spent. So we know that 20, so we know that 20 all minus x is going to equal to 15.17 because this x represents how much he spent on that milk and then the bread. So if we look here, in order to solve, what we can do is we can just isolate the variable on one side of the equation. So we're going to take 20 away from both sides. So we see here is we get negative x. That is going to be equal to Let's see what 15.7 minus 20 is. We know in our heads that since we're taking away more than what we have, it's going to be negative. I'm going to make an estimate. It looks like it's going to be negative 4.83, but let's just do it just so we can make sure. 15.17 all minus 20. Yeah, negative 4.83. And then I want to get rid of the negative, so divide each side by negative 1. And we see that x is equal to $4.83. So that is the total cost of both the bread and the half gallon of milk. Continuing on with our story problems. All right, so here we have a hike that began at 8,265 feet. That'd be crazy. The Everest is 29,000 feet, so we're not going to start at 82,000 feet. So the elevation of the mountains is 14,496 feet. We're writing an equation to show the elevation gain from the beginning to the summit. All right, so let's see here. It looks like they started here at 8,265 feet. Then they went up some distance and finished at 14,496 feet. All right, so therefore all we do is we're going to take away 8,265 from each side. So we get is we're going to get x is equal to, let's see here, so we get 6 minus 5 is 1, 9 minus 6 is 3, 4 minus 2 is 2, and then 14 minus 8 is 6. So it looks like it's going to be 6,231 feet. It looks like that's going to be our elevation gain. Again, I think it's good to double check our answers, so I'm just going to go ahead and double check that. So we got 14,496 feet, all minus 8,265 feet. That's going to be 6,231 feet. So that is the elevation gain from the beginning all the way to the summit. All right, let's look at another story problem. JFK elected in 1960 when he was 43. So what year was he born? So we can say x all plus 43 equals 1960. Take 43 away from each side, because we can see here that 43 is going to get x by itself, and whenever we're trying to solve for the unknown variable, we want to isolate it on one side of the equation. And again, we call it an equation because there's an equal sign in the middle. So therefore, 1960 minus 43, that looks like it's going to be 1917. Yep, because 1917 plus 43 would give us 1960. All right, so he was born in the year of 1917. All right, so now it's your turn to create two situations, one that uses subtraction, one that uses addition, that can be represented by an equation that contains a variable. All right, so yep, we went ahead and did this in class, just trying to come up with two situations. So I guess one situation would be, if I bought a PlayStation for $200, and I also bought some Beanie Babies, and the total cost was $250. How much did I spend on Beanie Babies? So therefore we could see that it would be 200, all plus x equals 250, and therefore we could see that x would be equal to 50. So that'd be $50 that would be spent on Beanie Babies. Okay, yeah, that's just a joke from a TV show I like, that one of the characters said they spent all your money on PlayStation and Beanie Babies. All right, let's look at another situation. So let's just say you went to the store with $100 and you spent some money on groceries and you got $40 back. So how much money did you spend in total? Here again, we're just isolating variable on one side of the equation. 40 minus 100 is going to be negative, because we know that we're taking away more than what we have. So we have negative x equals negative 60. And then just to go ahead and get rid of that negative, we can just divide each side by negative 1. So we're going to get x is equal to, in this case, $60. Okay. So those were two example equations that you can just come up with off the top of your head. So a couple situations. So I had one that used subtraction, one that used addition. So you went ahead and did the practice set in your notes. And then again, our objective for lesson 3, addition and subtraction word problems, was being able to write and solve word problems involving subtraction and addition to find missing numbers. Here was the solution to some of your lesson practice set questions. And then we're going to go ahead and skip over the homework 2 answers for now. And then the lesson 3 homework was the starred problems 8, 12, 14, 28, and 30. All right. Thank you very much and have a wonderful day.